Hello everyone. In the earlier video, we have seen how to plot the graphs of sin x and cos x. And while doing that, I first tabulated the values. We found out the values of, let's say, sin x. When we found out the value of y is equal to sin x, we put the values of x. We found out the values of corresponding values of y. We had that table and then plotted on the graph. In this video, I am going to introduce you the graphs of tan x, cot x, sec x and cosec x, and while doing so I am not going to plot the, let's say, tables again. I am not going to make the tables again. I am going to leave that part to you. I will just use whatever my knowledge is to plot these graphs and then tell you the domain, range and periodicity of these functions. So we have y-axis, x-axis, okay, and here what we are going to do is we are going to just have a little variation. In this case we will have on x-axis one division is equal to 30 degrees again, but on y-axis we will have one division is equal to 0.5. So okay, so this is how our scaled graph looks like. Now we know tan of 0 is 0. Okay, so the first point for the value 0 we have 0, the clean one. Okay, then tan of 30 is what? 1 by root 3 and it's approximately 0.6. so for 30 degree, okay, so then tan of 45 is 1 and tan of 60 degrees 1.7, right? And then as x tends to 90 degree, tan of x is equal to, it's going to infinity. So these are the points. So at 30 degree, okay, so at 30 degree, so this point we have 0.6 value. At 45 degrees we have 1, at 60 degrees we have 1.7, and as we know, as the value of x is going towards 90 degrees, right, then the value of tan x is going towards infinity. Okay, now what for the negative side? So tan of minus 30 is minus 0.6, then tan of minus 45 is minus 1, and okay, and then I connect them by the smooth graph. So this is the graph looks like. So again I want you to have this attention at, okay, so at 30 degree the value is 0.6, at 45 the value is 1, at 60 degree the value is, but what is happening then? Okay, as the value goes on increasing, the value rises very steeply. The graph is like, remember, try to understand here that after a particular range the graph will look more and more parallel to this line. It is never going to cross this line, that is x is equal to 90. It will never cross this line. Why it will never cross this line? Because wherever it crosses that line, it will mean that tan 90 will have that value, but we know this value is infinite. This does not exist. So this graph will get more and more straighter and will never cross this line. So this is the part. Now what after 90 degrees? So if I again do the same thing, use the values, okay, so you have to find the values of tan 180, tan 210, tan 225, 240, etc., and then again plot this. So this is how the graph looks. Okay, so it's going to repeat over and over and over. Okay, so as we can see here, the value of tan is not defined at 90 degree, then at 270 degree, right? The graph is just vanishing, right? It's going to infinity on. So if we go towards like towards tan 90 from the lower sides, right, so the value is going towards plus infinity, but if we have tan 90 from this side, so it does not exist. What is domain then? So domain is all the real values except for 90 degrees, 270 degrees. What are 90 degrees, 270 degrees? They are odd multiples of 90 degrees, that is odd multiples of pi by 2. So I will write domain as r minus odd multiples of pi by 2. 2n plus 1 is the odd number, right, odd integer, where n belongs to z, any integer. Now what is range? Range is r. As we can see, the value of tan can go from minus infinity to plus infinity, and no value is skipped, so all the values are there, so range is R. And what is periodicity? Now here the graph is repeating, like if I take this portion minus 90 to plus 90, that is being repeated over and over from minus infinity to plus infinity. So the periodicity is pi, which is 180 degree. If we move further and try to plot the graph of y is equal to cot x, so again we will have all those things. Okay. I will so plot all this. Now we know that cot 0 is not defined. Okay. So cot 0 is not defined, but cot 90 is 0, correct? And then cot of 60 is equal to 0.6, cot of 45 is 1, and then we will connect all this and then repeat the graph again and again. So this is how the graph of y is equal to cot x looks like. So here the values are not defined at 0, 180 degrees, 360 degrees, that is multiples of pi or multiples of 180 degrees. So what is domain? So domain is r minus n pi. So we have all, like, value of cot x is defined everywhere except for the even multiples of except for multiples of pi, integral multiples of pi. The range is r here also, as the values go from minus infinity to plus infinity, the value of y. And the periodicity, the graph is repeating itself after pi radians, that is 180 degrees. Now let's again move further and have this graph ready to plot the graph of y is equal to sec x. As we know, sec is the reciprocal of cos, right? So cos of 0 is 1, so sec of 0 is also 1. So at 0 we have this point, right? So sec of 0 is 1, but what is sec of 30? So sec of 30 is reciprocal of cos of 30, which is 2 by root 3, and it's 1.15, so we are plotting it here, right? Okay, now what is sec of 45 is root 2, it's 1.4, and sec of 60 is reciprocal of cos 60, which is 2. So I am plotting this, and then we will find the values for negative terms also, right? So this is the graph, this portion, then we will take the values on the negative sides. Okay, so as you know the values of cos at the different angles, just find its reciprocals, then plot the values and plot this graph. Okay, so this graph which we have plotted here. Okay, so this is the graph of cos sec x. Now here this understanding is very, very crucial, that the graph of cos was like this, right? Okay, and as you can see, when the value was value of cos was 0, the value of sec is going towards infinity, correct? And when it is going to 0 from positive side, it is going to plus infinity. When it's going to 0 from negative side, it's going to minus infinity. I'm sure you can find the correlations here if you learn it properly, but this is how we can plot the graph. You can, as I have told you, do the tabulation form yourself and do it. Now here again, like the graph of tan, the values are not defined for 90 degree to 70 degree. The problem with tan and sec is same. Both of them have cos theta in their denominators, so cos x in their denominators, and cos becomes 0 whenever the angle is odd multiple of pi by 2, and that's why the domain of sec x is same as domain of tan x, and it is r minus odd multiples of pi by 2. Here the range is from minus infinity to minus 1 union 1 to infinity. As you can see, okay, the graph goes here to infinity, but the value can come up to minus 1. The value can be minus 1, but not between minus 1 to 1. Here the value, this is the forbidden, these are the forbidden values. these values are not possible for sec, and then from 1 to upper values infinity. Okay, so that's why we are writing the range as minus infinity to, here we are writing this range, right, from minus infinity to minus 1 union 1 to infinity. And okay, the periodicity is 2 pi, as you can see. So just as cos or sine, the value is repeating from here to here, so which is, as you can see, it's 360 degrees, and that range is being repeated over and over, and that's why the periodicity is 2 pi. So one more graph is remaining, so let's do our part. I will use the same scales and all again. So here we know cosec is reciprocal of sine, so sine 90 was 1, sine 270 is minus 1, so we can get these points first. Reciprocal of 1 is 1, right? So that's why these points are there. Now we will find the values of sine and take reciprocals at the respective angles. So as we know, sine of 30 is half, sine of 150 is half, so cosec of 30 and 150 it's going to be 2, reciprocal of half. So at 150 degrees also it is half, and at 30 degrees it's half, right? Then here at 210 degrees, sine of 210 degrees is minus half, so its reciprocal is minus 2, and we are able to plot these values. Okay, plot all other values, like for example for 60 degrees and all, okay, and just connect them, and then we get this graph. So here the domain, as we can see, it's r minus n pi. As cot and cosec, they will have same problem, both of them have sin x in denominator, and sin is 0 when the angle x is multiple of pi, and that's why we are removing those parts. So we have the domain as all the real values except for multiples of pi, integral multiples of pi, and the range is again same as sec, that is minus infinity to minus 1 union 1 to infinity, and the periodicity is 2 pi again. You can observe this graph carefully and understand what I am trying to say here. So let's sum it up. Domain, range and periodicity of the functions we know. So we'll write function, domain, range and periodicity. Let's take the first function as y is equal to sin x. Its domain was r and range minus 1 to 1 and periodicity 2 pi. For cos x also, domain was r, range minus 1 to 1 and periodicity 2 pi. For tan x, domain was r minus 2n plus 1 pi by 2, where n belongs to z. So all the odd multiples of 90 degrees. Why we are skipping those values? We are taking all the real values except for this, because there tan x does not exist, as its denominator becomes 0. And range is r and periodicity is pi. For cos x, the domain is r minus n pi, range is r and periodicity is pi. For sec x, the domain is same as that of tan x, and for sec x the range is minus infinity to minus 1 union 1 to infinity, but it can also be written as r minus round bracket minus 1 to 1. So if we want to take the values from minus infinity to minus 1 and then 1 to infinity, what we have to do is we have to take all the real values except for only the values between minus 1 and 1. So they are same. So periodicity is 2 pi. And then for cosec x, domain is r is equal to r minus n pi, and the range is minus infinity to minus 1 union 1 to infinity, minus 1 and 1 included, and the periodicity is 2 pi. See, you have to give some time to yourself, try to plot the graphs, try to understand how it is, the values are changing with the change in the angle, and try to understand it better so that we can use it in our further learning. Thank you very much. So here I am going to end this series, and we will have few problem solving sessions added into this series later. Thank you.